Thermal conductivity is a fundamental property of materials that describes their ability to conduct heat. Among various materials, metals are known for their high thermal conductivity, which plays a crucial role in a wide range of applications, from cookware to electronics. This property arises primarily due to the atomic structure of metals. In a metallic bond, atoms are arranged in a lattice structure, allowing free electrons to move easily throughout the material. These free electrons act as charge carriers, transferring thermal energy effectively from one part of the metal to another. When heat is applied to one end of a metal object, the energy excites the atoms, causing them to vibrate. These vibrations are passed on to neighboring atoms, but it is the free electrons that facilitate rapid energy transfer over longer distances. Different metals exhibit varying degrees of thermal conductivity, influenced by factors such as atomic mass, bonding, and crystalline structure. For example, copper is one of the best conductors, with an exceptionally high thermal conductivity. This property makes it ideal for use in electrical wires and heat exchangers. Aluminum, while slightly less conductive than copper, is also widely used in applications where weight and corrosion resistance are critical, such as in aerospace and packaging. On the other hand, metals like iron and stainless steel, though still conductive, do not match the thermally conductive performance of copper and aluminum. Their lower conductivity is often compensated for by their strength and durability in various structural applications. Beyond pure metals, alloys can exhibit different thermal conductivities depending on their composition. For instance, brass, an alloy of copper and zinc, provides good thermal conductivity along with enhanced resistance to corrosion and wear. The temperature of a metal also affects its thermal conductivity. Generally, as temperature increases, so does thermal conductivity for most metals, although this is not a universal rule. Some materials, particularly those that undergo phase transitions, can behave differently. Understanding these behaviors is essential in applications where temperature control is critical. In practical terms, thermal conductivity impacts everyday life significantly. It affects how we design heating systems, cookware, and even electronic components. Engineers and designers harness this property to ensure efficiency and safety. For example, in cookware, materials with high thermal conductivity, such as stainless steel with aluminum cores, promote even heat distribution, reducing the likelihood of food burning. Conversely, in electronics, materials with lower thermal conductivity are often used for insulation to prevent overheating. The advancement of technology also demands better thermal management solutions. As devices get smaller and more powerful, managing heat becomes paramount. This leads to the exploration of new materials and composites, often incorporating metals to optimize heat dissipation in modern devices. While metals are characterized by their high thermal conductivity, it's important to consider the broader context of material science. Insulators, in contrast, have low thermal conductivity and are equally vital in applications where heat retention or prevention is necessary. Understanding the balance between conductivity and insulation brings clarity in their applications, ensuring systems work effectively and safely. Thus, the study of thermal conductivity in metals opens up avenues for innovation. By manipulating materials at the atomic level, scientists can design new alloys that enhance thermal performance for specialized applications. This continuous exploration not only drives technological advancements, but also leads to energy-saving solutions in an increasingly energy-conscious world. In summary, thermal conductivity is a critical property of metals, dictating their applications and influencing everyday life. From producing heat-efficient cookware to creating reliable electronic devices, understanding how metals conduct heat remains an essential aspect of science and engineering.